Hello, guys. Today we will see this problem. Figure shows isometric view of a machine component. Draw following views. First, sectional elevation looking in the direction of x. So in this direction, we will see sectional front view. Then plan the top view and LHS view, left hand side view. So the outline for this diagram is front as the side view is asked, right? As in this question, left hand side view is asked, so we will draw front view on left side, and on right side we will draw left hand side view. Okay, then below front view we will draw top view. So the dimensions of this rectangle for each view is: in front view the length is 108. See, this is 100 from left side to center point of cylinder, and then these radius is 20, diameter is 36, means radius is 18. So 108 lengthwise, and height wise this is 63. Then in left hand side view the dimensions are, in this direction dimensions are: horizontal dimension is 75 and vertical dimension is 63. And in top view, that is in this direction, vertical dimension is 75, see here, and horizontal dimension is 118. So this is how our outline look. Now we will draw front view. First we will draw front view in this space. So for front view, the starting point will be here. This point is a 0 point for front view. So here in question, the 0 point will be at the bottom of the cylinder right surface and extreme right. Okay, this will be our starting point. So from this position, from this point, the height of this cylinder is at, the top surface is at 63 mm. Then the cylinder has a height of 25, right? Also the cylinder has dimensions as 36 diameter, and in front view this cylinder will look like rectangle of 36 mm width and height 25 mm. Now we have to draw a sectional elevation, that is sectional front view. So we will cut sectional elevation along x. So along x the section is this section, section AA. It is shown here, A point and A point. This is the section AA. We will cut this object into two parts along this section plane AA. Then the material which is cut, we will show this material by hatching. Okay, and excluding stiffener. So this part is support part called as stiffener. We will exclude this part. We will not draw hatching on this part, only we will draw hatching on this area, then again this area. Okay, two small rectangles here. Then the plate base, the cross section of plate base. Sectional view is used to show the hidden geometry in the object. Hidden geometry in the object. Okay. So first we will draw this rectangle here. So this top surface is a extreme right side. It will be here on right side. It has a depth of 25. So I will mark 2.5 mm, 25 mm from here. Then the cylinder has a width of 36. So 36 mm from this point. This is 36 and the length is 25. Length is 25. Then this base plate is on extreme left. right? The base plate has a cross section as total width as 56. Then in at the center 16 mm on both sides there is a rectangular gap or rectangular material removed at height of 6 mm. So first we'll take a 56 mm on extreme right, and on this line we will take a midpoint, that is in the mid of 56 is a 28. Then from this 28 point midpoint we will take 16 mm on both sides, 16 mm on both sides. Then we will erase this part, and as material is removed and its height is 6 mm, so 6 mm we will mark 6 mm and draw this line like this. So this is our cross section of base plate. Then this plate has a height 18, so from this point we will take 18 mm, and also here from this 18 mm. And connect. So from this point connect this point, and from this point connect this point. Then this cylinder has a cylindrical hole. The hole has a diameter of 22, and hole and cylinder has the same axis. So first take, as 36 upon 2 is 18, first take the midpoint and take 11 mm on both sides. So for that, first draw central axis, then 11 mm on both sides. Here also it has a cylindrical holes, and the distance between center and left extreme point is 28. So at 28, and the diameter of cylindrical hole is 12 mm. So first draw a center line from this midpoint, and from this center point draw 6 mm on both sides. This is how our front view will look like. Now we will draw sectional view, that we will draw a 45-degree inclined lines. The shortcut to take 45-degree lines is take this point and this point on a scale and a roll scale, then draw hatching. Approximately take 2 mm distance between two lines and approximately 45-degree line. Don't waste too much time doing this. So in sectional front view has a mark, it has a 6 marks out of 15 marks. Out of 16 marks, sectional front view will have 6 mark. Then top view and LHS view will has 5 mark, 5 and 4 mark each. The 4 mark will be for that view, which is simpler. So this is how our sectional will look like. Okay. Then we will draw top view. So to draw top view with the help of 2H pencil, just take projection in top view area. The projection line should be very faint. Then, as in question, center line is given, and this center line is at a distance of 75 upon 2 from this end on both end. That is, it is at center of the top view horizontally, right? So first we will draw the center line by taking 75 upon 2. So 75 upon 2 is 37.5. So approximately we will take point in between 37 and 38 mm and draw a center line passing through these points. And then so this plate has a width of 56, and so we will take this 56 so in top view this portion is not visible, right, due to stiffener. So stiffener we will draw stiffener from this point, that is left extreme point, up to cylinder's first point. So cylinder's first point is here in this on this line, and 12 mm total means 6 mm on both sides. So we will mark 6 mm on both sides from center line and draw line parallel to this center line up to this line. You can see here stiffener part is straight up to 35 mm. So I will just erase this part. From center line mark 35 mm. 1, 2, 3. 35 mm. Draw horizontal line and then join this part. Now we will take projection of this point also. And as this is a rectangular part and this is the inclined rectangle, so plane changes. So if plane changes, then we have to draw this dark line. Then so this is a stiffener, top view of a stiffener. And now we will draw this cylinder circle, top circle of 36 mm diameter. Center point will lie on center line. The diameter radius is 18 here, and we'll draw circle of 18 mm. Inner circle is of 22. We have taken projection of inner circle. So this is our top view. These two circles remain. Now on this center line, first I will draw center line in top view area throughout from this surface to this surface. Then The circle center point is at 15 mm from this side. From this side, circle center has a 15 mm, and the radius of circle is 6 mm. So first take 6 mm, and at 15 mm point I will draw a circle of 12 mm diameter. Then if you have drawn circle, then there must be center line passing through center horizontally and vertically. Then we will draw left hand side view. So left hand side view will we will change this direction. For front view, this will be this was direction. Then for top view, this was direction. Now in front view, in left hand side view, we will change the direction to this. Okay. So in left hand side view, first we will saw this rectangle, then this stiffener part, right? And behind this there is a cylinder. So first we will take projection of horizontal lines and important points on this 45-degree inclined line. Draw this 45-degree line with the help of protractor, and then take projection of each point on this line. Then take vertical projection of these points. Now this is it becomes very complicated, but just draw very faint lines, and it will help you as a reference line. Then draw horizontal projection of front view. Now first we will draw this rectangle. So I will mark this is our first point. Then rectangles span is 75 and 18 mm. So this is 18 mm, right, on this line up to this extreme line, and this is 75. Then we will draw the cylinders. So cylinder will look like a rectangle in left hand side view, and cylinder's center point, that is axis, is situated at distance of 75/2 from this side. So cylinder's axis is here, and from this point on both sides. So cylinder has a diameter as 36, so 18 mm on both sides. This is one. Cylinder has a height of 25, Now we will draw stiffener. So in left hand side view, this inclined plane stiffener will look like a rectangle joining this point right to this point. So stiffener's projection here. So join this line, make it dark only with this. Now draw a center line for cylinder. And then draw center line for this circle. This is a center point. Then take projection. Now center line of cylinder or cylindrical hole, it should cover somewhat upper part and lower part. That is, it should be drawn from line above, that is plane above this cylinder and behind this cylinder. Okay, but the dotted line should be only up to the surface, that is upper surface and lower surface. This is how our left hand side view will look like. Now these rectangular cut, so during in left hand side view, this line, so this is a rectangular cut, so this upper line will look like a dashed line in LHSP. So we will draw a dashed line from this point to this point. And here also, this cylindrical hole, this should be dashed line. Now we will erase this rough part and draw dimension as mentioned in question. If in question suppose total 12 dimensions are given, then you can draw dimensions 4, 4, 4, that is almost approximately equal on each view. So here total 16 dimensions are given, so we will draw approximately 5 dimensions on each view. So in front view, which dimension is mostly visible, we will draw this dimension in front view, and likewise for top view and left hand side view. So the diameter is visible in top view, so for diameter we will draw arrow passing through center point up to opposite point of circumference, and then a faint line passing through this arrow on the outside diagram, up to outside diagram, and we'll mark this diameter is 36 mm, so symbol of diameter is phi and the value of diameter. This is 22 mm diameter inner circle. Then this 25 mm depth is visible here in left hand side view. We can draw this 25 mm here also or in front view also, but it is clearly visible in left hand side view, so I draw it. Then this circle diameter, the whole diameters are 12 mm. So this is how our final diagram should look like. 1 2 3 5 6 1 2 3 4 5 5 dimensions here, and approximately 5 dimension on each view. Extension line parallel to these axis, and in between there is a dimension line with arrow field on both sides. Dimensions quantity, that is this is written outside of diagram,